Phew. All right. You got through multiplying. We've done adding and subtracting. Now we're going to move right on into division. And before you start to curl up your nose and think, gross, yuck, I don't like dividing, it's not as bad as you think. Trust me. Okay. In a sense, it's kind of like repeated subtraction. And we'll talk a little bit about how that relates. We're going to split it into two chunks, however. And today we're going to focus on just remembering the decimal parts of rational numbers and division. And the next time we will do fractions. Yay. So, your essential question: how do I divide rational numbers? I want you to think on these two questions. First, start with this one. What does it mean to divide by 2? What does that really mean? Divide by 2. Divide by 2. Think about that for a second. If someone's around you, pause the video, talk to them a little bit. What does it mean to take half of something? Okay. So let's say if I have a bunch of pizzas, or even if I just have one pizza and it's cut into a bunch of slices, or maybe you get the ones that are cut into little squares and you're trying to think of dividing by 2 versus taking half of something, the final result is really the same answer. But we're going to dive deep into going way, way, way back into thinking what it means to divide by 2. Okay. So let's jump right here right away. What happens when we divide 12 by 2? Okay, I want you off to the side. I've got 12 little circles there, but I want you to remember the algorithm for long division here. When we say 12 divided by 2, then we started having you write it this way: 12 divided by 2. And you started asking yourself, how many 2's fit into 12? So in a sense, when you first started learning division, maybe you were taught a way where you just started counting up by 2's: 2, 4, 6, 8, 10, 12. Maybe if you were pretty solid in your multiplication facts, you started thinking, all right, 2, what's my fact families with 12? 2 times what gives you 12, and so on. Now, I'm hoping you already get to this point. Yes, yes, my answer is 6. But here, I want you to think of it this way: group by 2's. I have 2. This is kind of like that count up method. Here's 2, here's a group of 2, here's a group of 2. If you want to get fancy and do some this way, here's a group of 2, here's a group of 2, here's a group of 2. And you end up with 6 groups of 2. Okay? So if I use that same logic about this grouping, I can make 6 groups of 2's. If I use that same logic down here, where it says, what happens when we divide 12 by 1/2? I'm asking you, how many groups of halvesies can you make? Think about that. Divide each of these into half. And they look like some weird colored Pokeball or something at the moment to do. So now if I said, how many groups of 1/2 do you have? I hope that you understand that you end up with a larger number, 24. What happens when you divide by a number less than 1? I'm asking you how many groups of something even smaller than 1 you get. You should get a number much larger than what you started with. Let's remember how we went about this, okay? The long division algorithm that you were probably taught said this: 427 divided by, and 1/10 or 0.1 is your divisor. Now, we said it's really hard to think about dividing by something smaller than 1. So it's equivalent if we take these two, and even off to the side here, even if I wrote it as a fraction like this, it might be easier to understand why it's okay to do this. Do you remember how you moved the decimal point over? So really what you do when you're doing this is you're multiplying the divisor by 10. And the only way that that's legitimate to keep and preserve the same value is multiply 427 by 10, which means move that decimal place one spot over as well and put it up there. Because 10 divided by 10 is 1. I haven't changed the value of this division problem or that quotient, because if I multiply this number by 10 and multiply the denominator by 10, it's the same as multiplying by 1. So do you remember doing this? If you move the decimal point over by 1, decimal place, that's a 10. Do the same thing here, and then you divide, and look what happens. I end up with just dividing by 1 now, which is, boom, easy peasy. And you probably don't even have to write any of this stuff under here. You get 4,270. You end up with a larger number when you divide by something less than 1. That's the first thing I want you to go to, is to kind of estimate what your answer is so that you can remember what you're doing. Okay. Now, notice this is all fraction land. Okay. So up to here, we're going to wait and do that next time. But now we're going to throw signs in there. So you have to remember what's going on sign-wise and the rules, which are just the same as multiplication. 12 divided by negative 4. A positive divided by a negative. 12 divided by 4 is 3. Then just divide the absolute values. A negative divided by a positive is a negative answer. 12 over 4 is 3. What if the negative sign is way out here in front and I have parentheses here? Then what I want you to think of this as is this negative sign, sometimes we read it as the opposite of, okay? So I want the opposite of 12 divided by 4, which is 3. The opposite of 3 is negative 3. In other words, keep this sign here in parentheses, simplify or do that division, and then keep that sign with it, okay? Let's look at some more now, specifically with some decimals. I don't want you to do these. We'll do those next time. Here are the rules again. Remember, different signs, positive, negative, or negative, positive. You get a negative answer. Same signs, get a positive answer. And maybe it'll even help you to say something about different signs and same signs. Always 2 answers at a time. Okay, let's see what's going on here. Over 5 months, Carlos wrote 5 checks once a month for a total of $323.75 to pay for his cable TV service. His cable bill is the same amount each month. What was the change in Carlos's bank account each month to pay for cable? Now, because you're paying, they want you to think of this as a negative value, okay? And then divide by 3. So in a sense, your final answer, they want you to think negative, and we're dollar signs here. Now off to the side, simply go ahead, just use the absolute values, in other words, 323.75, and divide by 5. And yes, do this the old-fashioned way. 5 can't go into 3, but it can go into 32. Oops, put your decimal point up there right away. Continue on with your division till you get your final answer. That's a 35. I subtract, I get a 2. Bring down the 5. And then I get 25 with no more remainder. Hip hip hooray. It looks like the bill is $64.75 each month. It changes, his bank account changes by going down or by a negative $64.75. If it makes more sense to you to just say $64.75 without a negative sign, then say that his bank account decreases by this amount each month, or it decreases each month. Okay? Use words or use the sign. just to indicate which way is it going. Is it increasing? Is it decreasing? All right, take a look at number 5. It looks totally strange to have this written as a fraction. So I say rewrite this in good old-fashioned division sign method. And then first decide on the sign of your answer. Different signs, negative. Then go ahead and use the old-fashioned algorithm using just the absolute values. Since I'm dividing by a whole number, all you have to do is bring that decimal point directly up above. 4 can't fit into 2. It can fit into 24 6 times. Boom chakalaka, you are done. 0.6. Let's look at one last one here. Notice, decide on the sign of your answer first. And then rewrite this as a regular division problem. 1 second here. Ouch. Okay. Divide by the number in the denominator, which is 5/10. I know this looks totally gross here, but you've already decided on your sign. So then do this. 5 and 5/10 divided by 5/10. Okay. Now you're going to have to pull that multiply by 10 to shift the decimal point out here so that way you have a whole number. But you have to do the same thing right there. Now it's simply 55 divided by 5 and boom, boom, that's 11. Boom, boom, 11. Ta-da! All right, check Schoology for your assignment today. Watch your signs, watch that decimal point. Good luck. May the force be with you.